Okay, so today what we're going to talk about is domain and restricted domain. So recall what the definition of a domain is. The domain are all your x values. Okay, so look at the expression x plus 4 divided by 2x and tell me what x can't be. Like, what can't I plug in for x? So notice that in the denominator I have 2x. So remember, when you have a fraction, you can't have 0 in the denominator. So if x is equal to 0, then it's undefined because 2 times 0 would be 0. So x cannot be equal to 0. So x can be any number, but it can't be equal to 0 because then it would be undefined. Okay, so finding the domain from an equation. Sometimes, instead of thinking of what you can have, think of what you can have, thus leading to what you can have. So you want to think of maybe the opposite. You don't always have to do it like this, but sometimes it's easier to think of it like that. So domain and restricted domain is understood to be the largest set of real numbers for which the function is defined. Okay, so let's take a look at the first one here. It says find the domain, and then we're going to write it in interval notation. It's a little cut off on the side. All right, so my function is f of x is equal to 2x minus 9. So what could I plug in for x for this equation? Is there any number that x can't be? Could it be 0? Yeah, because 2 times 0 squared minus 9 is negative 9. It could be 1, it could be 2, it could be negative numbers. So actually, the domain for this equation is all real numbers. It could be any number on the number line. Sometimes you can see all real numbers written like that. So that would be from negative infinity to positive infinity. All right, so take a look at number 2. I have 5 over x plus 9. So what can't x be? So if you can't figure it out, say to yourself, well, it's a fraction. And I know that in the denominator, x plus 9 cannot be equal to 0. Because if x plus 9 is equal to 0, then it's undefined. So minus 9, x cannot be equal to negative 9, which means it can be any number except negative 9. So it's all real numbers except negative 9. And you would write that from negative infinity to negative 9, parentheses, because it can't include negative 9. Union, that means or, negative 9, that's negative 9, comma, to infinity. All right, let's take a look at 3. You have a radical. So think about what you can't have with a radical. You can't have a negative under the radical. This number under here can't be negative because if it's negative, then it is imaginary. It's not real. So x minus 3 has to be greater than or equal to 0 because it can be equal to 0. The square root of 0 is 0. It just can't be negative. So it has to be greater than or equal to 0. So add 3. X has to be greater than or equal to 3. So that would be the domain. X is greater than or equal to 3. So my interval notation would be bracket 3 to infinity. Okay, let's take a look at 4. So it's almost like the same as number 3, but it's a fraction. So it's like two things going on here. You have a radical, can't have a negative under the radical, and it's a fraction, and it can't be 0 in the denominator. So therefore, x minus 3 has to be just greater than 0. It means it's going to be positive, but it can't be 0 because then it's undefined. So add 3. X is greater than 3. So that's your domain. X is greater than 3. And interval notation would be 3 to infinity. Okay, so we're going to talk about the difference quotient now, so flip it over. Okay, so we're going to talk about the difference quotient and where the difference quotient comes from. So I have my axes drawn here. So this is some x value. I don't know what x value it is. I just know it's x. And then this is my y axis, right? So I have x-axis, y-axis. And I'm going to label this f of x. Because remember, f of x is just another way to label y, to represent y. So I have this point here. And then I could label this point as x, right? My x value first, comma, my y value, which is f of x. Now, let's say I increase my x by some unknown number. Let's say h. So then this point here would be x plus h. And then therefore my y value would be f of x plus h. So this point up here would be x plus h, that's my x value, comma my y value, which is f of x plus h. So the difference quotient comes from finding the slope between these 2 points. So remember the slope formula is y1 minus y2 over x1 minus x2. So I'm going to subtract my y's and subtract my x's. So I'm going to subtract my y's. There should be another parentheses there. I'm going to subtract my y, so that's f of x plus h minus my other y, which is f of x, over subtract my x's. So I have x plus h minus x. And then in the numerator I have f of x plus h minus f of x over, and then my x's cancel out because x minus x is 0 over h. This is called the difference quotient. All right, so now we're just going to apply this. All right, so take a look at number 1. I have f of x is equal to negative 2x plus 4. It says find f of x plus h minus f of x divided by h, the difference quotient. And notice I have here h can't be equal to 0 because then it's undefined. So you don't need to worry about this, okay? It should be written because it is a fraction and you have a variable in the denominator. All right, so remember, this here is my input. So wherever I see an x over here, I'm going to plug in x plus h. So I have negative 2 times, plug in my input, which is x plus h, plus 4. And then I'm subtracting f of x. Well, f of x is negative, parentheses, 2x plus 4, all over h. Okay, so I'm going to distribute. So I get, I'm going to write it down here actually, negative 2x minus 2h plus 4, distribute the negative, plus 2x minus 4 over h. Okay, so let's see what we get. We have negative 2x plus 2x is 0. I have 4 minus 4 is 0, so I'm left with negative 2h over h. H divided by h is 1, so I'm left with just negative 2. All right, so let's take a look at number 2. So I have f of x is equal to 5x minus x squared. I have f of 5 plus h minus f of 5 over h. So I have an input. This is an input and an input. Okay, so wherever I see an x, to start off with, it's going to be 5 plus h. So it's going to be 5 times 5 plus h minus 5 plus h squared minus, now f of 5. So 5 times 5 minus 5 squared all over h. Okay, so let's see here. Well, let's start with this guy right here. So let me do that right up top here. So 5 plus h squared is 5 plus h times 5 plus h. So that's 25 plus 5h plus 5h plus h squared. So I'm just going to plug that back in. I'm going to combine like terms because that's 10h. And I'm going to distribute here. So I have 25 plus 5h minus, now this trinomial I'm going to get, 25, 5h plus 5h is 10h, plus h squared. And now let's distribute that negative there. And this here, actually let's just take care of this part here. So I have 25 plus 5h minus 25 minus 10h minus h squared. All right, and then we have inside here, so this is 25 minus 25, so that's minus 0 here, all over h. Okay, so let's see what we have. We have 25 minus 25. Get rid of that 0, we don't need it. We have 5h minus 10h, that's negative 5h. And then I got minus h squared, all over h. Okay, I can make a heart and reduce. So h and h reduce, all those 3 h's reduce to 1, 1, 1. So I have negative 5 minus h. And that's it. Or you could write it as negative h minus 5, same thing. Okay, so that's it, and we'll practice more in class tomorrow. Have a good night.